Arrays can be passed to functions just like vectors can. There's a couple of differences though. For one thing, when you want to modify the contents of an array in a function call, you don't have to pass the array by reference. You can just pass it by value. I'll explain in a later chapter why that's so. Another difference is when you pass an array to a function, you also need to pass its size, since there's no way internally for the function to know what the upper bound of the array is, so you need to pass some way to tell the function when to stop processing elements of an array. Let's look at a few examples of using arrays with functions. You'll notice I've already pound included the standard lib library and the time library so that we can generate some random numbers. So the first function we're going to create, build array, will use those libraries to build an array of random numbers. So we'll call the function build array. The first parameter is the array itself. The way you pass it as a parameter is you provide a name and a pair of brackets that are empty. That tells the compiler that this object is an array and not just a regular variable parameter. Then the second parameter will be the size. Because we want to build this array using random numbers, the first thing we need to do is seed the random number generator. So we'll do that first. Now we're ready to populate the array with random numbers. So we're going to loop through the array, starting at 0, working to 1 less than the size, incrementing by 1 each time, and simply assigning each value of the array a random number. And we'll do it in the range of 1 to 100. So that's all we need to do to build the array. Now let's write a function to display the contents of the array. Same parameter list as the first function. This time all we want to do is loop through the array and display each element. So we just write it out to the console. And let's put a space between each element. And that's all we need. So now we can use these functions in a program. So the first thing we want to do is create a size for the arrays we're going to build. We'll make it 10. Then we'll declare an array. Let's call it grades. And we'll use size as its size. And then let's call the two functions, build array with grades and size, to build the array, and display array with grades and size to display the contents of the array. Let's build and run the program. And there's our array of 10 elements. So what can we do with these arrays? Well, we can do like we did with vectors, and we can curve the grades. That would be one thing to do. Let's go through that real quick, mostly as review because it's the very same function just about, other than the fact that we're using an array instead of a vector. We're going to loop through the array. Well, let's do one thing. Let's go ahead and also add an amount that we want to curve so that we don't have to modify that in the body. So for I less than size plus I, array sub I plus equal amount. We'll curve the grades by whatever amount we specify in the function call. So let's come down to the main program. We'll call curve grades with grades and the size. Then we want to display the array again to see how the curving went. And then we'll write a new line at the end. Okay, so build and run. Oops, and we forgot the amount. Let's say 5 points. And there we can verify that indeed each grade got curved by 5 points. Oh, I feel sorry for that person that made a 1 and that person that made a 6. But at least they got 6 and 11 instead. Okay. So you can see that there's really not a lot of difference between using arrays and using vectors, at least in function calls. The primary difference, of course, is the fact that we have to pass the size in each time, which is kind of inconvenient, but not that bad. Let's look at a different kind of function now. One of the things that an instructor will want to do is see what were the highest and lowest grades on any particular test or for the whole semester for all of his or her students. So let's write some maximum and minimum grade functions. Let's start with maximum first. We'll call the function maxGrade. It's not a void function. I was starting to write void out of habit here. But what we want to do is this. We want the function to return the position in the array where the highest value is found. That makes more sense than just returning the grade itself. It's nice to see what the grade is, and if we had it associated with a name somehow, then we could also, figure out who the person was that made the highest grade. So we'll make this an integer returning function. We'll call it max grade. Its parameters are an array and a size, just like the other ones. The way we're going to write this function, or the algorithm we're going to use, is we're going to assign a maximum value to the first array element, regardless of what it is. And then starting with the second element, we're going to compare that element to the maximum value. If that element of the array is larger than the maximum value, then that value becomes the maximum value, and that position in the array becomes the position that holds the maximum value. I think it'll be clear once I write the code. So we're going to write int max value equals array sub 0, signifying it's the first spot, and int position, which stores the position where the maximum value is set to 0. Then we begin looping through the array, starting at position 1 this time, going through or just until the size, same plus plus I. Then we write an if statement, and we say if the new array position holds a value larger than max value, then we want to assign that array's element to max value, and we want to assign that index position to the variable position, so it's going to equal to I. And that's all we have to do. Then when we're finished, we return the position that is left at the end of the loop. Okay, let's test that. So come down to the main program. We'll create a variable, we'll call it maximum, or we'll call it max position equals max grade with grades and size. Then we'll write out cout. The largest grade is, drop down to the next line, grades max position, and then an indel. Okay. Leave that indel there. No, actually, let's take it out and put it above. Control X and Control V, so we have some space between our last display array. Let's comment out. In fact, let's comment out these lines right here. We don't need them anymore, and they'll just muddy up our output. So to right here. And now let's build and run the program. So in this first run, the maximum value is 66, and if you do a quick scan, you see that that's true. Let's run it again. This time it shows it's 97. That looks good. We'll do it one more time. And it shows the maximum value is 98, and that's exactly right. So our max grade function works fine. Now let's write a min grade function. The good thing about this is it's almost the very same function. We just have to change the logic to look for the minimum value rather than the maximum value. So we use the same parameters. We'll create a new variable called min value and assign it to the first array position. We'll still use position and we'll assign it equals 0. We'll still have a loop. In fact, let's just copy this code, all of it. Control C, Control V. Then we'll say if the array position we're at is less than min value, then min value equals array sub I and position equals I. Don't forget at the end to close off the function body. Now let's come down to our main program. And right here we'll have a int min position equals min grade, grades and size. Cout. The minimum grade is grade sub min position. Indel. Let's build and run the program. So we have the largest grade of 100 and the minimum grade as 12. Let's do it again. This time we have 86 and 4, and one more time, 85 and 8. This is how we use arrays in function calls. It's very similar to how we do it with vectors. We just have to pass the size of the array with the array itself as parameters so that the function knows when to stop. Other than that, working with array values and working with vector values in function bodies are pretty much the same thing. In the next lesson, we're going to look at a different type of array which holds rows and columns of information. It's called a two-dimensional array.